So this video is about absolute value functions and then graphing them and then identifying some basic properties of them. So just like we've started the other videos, we'll start with the parent function. So the parent function here is going to just be the absolute value of x. So if I want to graph that, you know the line y equals x is the line like this. So going through the origin with a slope of 1. So then when I take the absolute value of x, what happens is that I'm not going to have any negative values for y, so it's going to bump everything below the x-axis up to this quadrant here. So let's just graph the absolute value function. So when x is 0, y would be 0. When x is 1, y would be 1. And when x is negative 1, the absolute value of that would be positive 1. So I'm going to get this v-shaped graph like this. Okay, so absolute value functions are going to be v-shaped. And the domain of this parent function, so I can choose any value for x and plug that in, and I'm not going to have any issues. So my domain is negative infinity to positive infinity, and I can see that on my graph as well. My range, I don't have any negative values for y, so the lowest I can go is 0, and then I can go as high as I want. So my range is from 0 and including 0 to infinity. My intercepts in this graph, I only have one, which is the origin. And then my axis of symmetry, so just like parabolas, I do have an axis of symmetry through this is also called a vertex here. And it's going to be the x-coordinate of the vertex. So my axis of symmetry in this graph is x equals, not 1, 0. Okay, so let's look at the general equation or formula for absolute values. So in general form, it looks pretty similar to a quadratic equation, and actually all the hk and the a mean the same kind of thing. So here, hk means the vertex again. Okay, and then same idea for the a. So if the absolute value of a is less than 1, then my my absolute value function is going to be wider than my original parent function. Okay, and then if it's greater than 1, my function is going to be narrower. The graph is going to appear narrower than my parent function. And if your a value is negative, then the v will open down. Okay, so let's see some examples. Okay, so I have 2 times the absolute value of x minus 1. So I see that 2 out in front, it's going to make the parabola, I know it's going to make it narrower. And then what I want to start with when I'm plotting the graph is maybe start with plotting the vertex. So I know that I have a plus 0 out here. So my vertex is going to be at 1, 0. So remember, you switch the sign with the x in the bracket. So my vertex is at 1, 0, so it's here. And then if I want to make a little table of values to see what's happening on either side of the vertex, I can do that. So when x is 2, if I plug that in here for x, I'm going to get 2 minus 1, which is 1, times 2 is 2. So when x was 2, y was 2. And then when x is 0, if I plug that in for x again, I'll have the absolute value of negative 1 is positive 1 times 2 is also 2, which is good. So it should be symmetric again about that axis of symmetry. So there's the graph of my function. If you recall the parent function, I'll plot it here in blue. So it looked something like this. So you can see what happened was that I shifted my parent function 1 unit to the right, and it got a little bit narrower because of that 2 in front. So the shift to the right came from this minus 1, and it became a little bit narrower because of the 2. So the domain of my example that I'm looking at is going to be negative infinity to positive infinity. Again, I can choose any values for x, not going to have a problem there. The range is again from 0, 0 is the lowest point of my vertex, but I can go all the way up to infinity. My intercepts, I have 2 intercepts. I have an x and a y intercept. So my x-intercept is that vertex at 1, 0, And my y-intercept, I can see it here, is at 0, 2. And my axis of symmetry is the line that will split the picture right in half, so it's at the x value of the vertex, which is going to be x equals 1. Okay, let's see one more example. So I'm starting off with the same, the first part of the function is the same as what I just graphed in the last one, but now I have this added -3 here, or I put that on as well. So my vertex then is going to be at 1, -3 now. So my vertex is at 1, -3, so down here. Okay, and then if I make a table of values again to see what's happening on either side of the vertex. So when x is, let's say, 2, if I plug that in here for x, I'm going to 2 minus 1 is 1, times 2 is 2, minus 3 is -1. And it should be the same thing when x is 0. So if I plug that in, I'll get -1. Absolute value of that is +1. Times 2 is 2, minus 3 is -1. So that's a good sign. So when x was 2, y was -1, and 0 -1. So I'm going to have something like this. Okay, so you can see that it's narrower because of the 2, and I've actually shifted the vertex here right 1 unit and down 3 units from my original parent function. So the vertex of my original parent function was here, so I shifted it right 1 unit and then down 3 units. Okay, so the domain of this function is going to be still -infinity to +infinity. It's not changing. The range, however, is I can never drop below -3. I can go as low as -3, but I can never, this piece here will never be negative. So I will have my range from, I thought I hit the stop record there when I did that circle, but I didn't. Okay, so I will go from -3 up to +infinity. Okay, in my intercepts, I see that I have a y-intercept as well as 2 x-intercepts. So my y-intercept is easy. I found it here in my table of values, so that's 0, -1. My x-intercepts are a little bit trickier. They're not nice whole numbers. So if you need a review on how to solve for those from the absolute value videos, make sure you go back and watch how to solve. So we would just set this piece here equal to 0, and then solve for x with the 2 different cases. So when I do that, I will find that I have 5/2 and 0 and -1/2 and 0. So this one here is the -1/2, and this one here is the 5/2. Okay, again, if you need a review on how to solve for these, make sure you go back and watch that video. And then the axis of symmetry, again, is the line that will cut that v right in half, so it is still at x equals 1. Okay, that's it. Thanks for watching.